Hi folks, this is Professor Mughal here. Welcome again to my YouTube channel. Today we are going to create a metal detector. So I bought this kit right here. It came in this plastic box from Amazon. It was about roughly $15, and there are actually two metal detector kits in there. So if you look at over here, it comes with this PCB design board, all the components, resistor, capacitors, triodes, light emitting diodes, potentiometer, everything comes with it, and all we need to do is actually put it together, solder it, and that will be our metal detector. So I thought I should do that and see if we can get this to work. This tutorial is also going to be helpful for those who are trying to brush up their soldering skills. So eventually I'm going to use this metal detector for my next video, which is going to be on a canned plastic solder. So let's get rolling. Obviously it also came up with the schematic, so we're gonna follow the schematic as we do the soldering, and everything is labeled on this PCB board, so that's good. Let's get started. So we all know that metal detector is an electronic device, and the operation of metal detector is based upon the principles of electromagnetic induction. When electric current passes through a coil, it produces a magnetic field around it. In this circuit, we have transistors and capacitors arranged in such a configuration that they make an oscillator, which then produces an AC current that passes through a coil, producing an alternating magnetic field. When a part of the metal is near to the coil, eddy current will be induced in the metal. This produces a magnetic field of its own. First, the capacitors get charged, and as soon as it gets fully charged, it starts to discharge the energy to the inductor. The inductor gets energy, and then again it gives it back to the capacitor. This process repeats itself and makes oscillation and has a certain resonating frequency depending upon the values of the capacitor. This part of the circuit activates the proximity sensor when it senses any metal close to it. The sensor glows the LED and makes a buzzer buzz. These rapidly changing magnetic field lines, due to current flowing in the coil, penetrate through metal surface and produces circulating currents called eddy currents on the metal surface. This eddy currents will create its own new magnetic field that affects the original one. This reverse magnetic energy is absorbed back, changes the inductance of the copper coil, and so do the frequency of oscillations. Now the two frequencies will be different, and thus the oscillator fails to maintain the original resonating frequency. Then the final transistor conducts, hence the buzzer and the LED is activated, and thus a hissing sound is produced.
So it's not very noticeable. I don't think if you can see on the scale or not, but if I bring this metal piece of the screwdriver close to the detector, it starts beeping. And this is about roughly 5 millimeters. And as I pull the metal, anything above 5 millimeter stops beeping. If I bring it closer to proximity, which is about 5 millimeter, just about here, starts beeping back again. So here you go, folks. There's your metal detector. It was so easy. It roughly took us like 10 minutes, really. I hope you enjoyed the video. If you haven't already, subscribe to the channel, and I shall see you in the next one. Thank you. Bye.